So as you know that TIFR answer key is released. So today I will discuss the IPHD 5 marks questions first, and then I will discuss this is the first part of the video of the 5 marks question. So I will discuss first 7 questions in this video. This is all 5 marks questions, and in the next part I will discuss another remaining 7 or 8 questions. Okay. So this is the first question of the 5 marks for IPHD. This is for IPHD. Okay. So this problem is pretty straightforward. It says that NLM is denote the energy eigenstates of hydrogen atom, non-relativistic hydrogen atom, with spin and A0 is the Bohr radius. So what is the matrix element? Okay. So now this, if you know the selection rule, then you will be done in 1 minute. Otherwise you cannot do it. So for IPHD students, this question I will say that most of the IPHD students don't know the selection rule very well. So it is for the PhD students, it's very easy, just a 1 minute question. But for IPHD, I will say it is out of track little bit. So I will say it is tough. Okay, for IPHD because we have to see from the perspective of IPHD students. Okay, so the x, you know that x is r sine theta cos phi, and cos phi is e to the power I phi plus e to the power minus I phi by 2. So if you take LZ of x, this there is I phi minus I phi. So here m is equal to 1, here m is equal to minus 1. Okay, so for the it should have a finite value. It has a finite value if these two states have a separation delta m is equal to plus minus 1. Okay, otherwise as you can see that here mz is 0, here mz is also 0. So it will have a non-zero value if this x is z, because z is r cos theta, there is no phi term. So then it will have a finite value, but here both mz is 0 and the term is x, and x is this, m is 1 and m is minus 1. So delta m should be plus minus 1, then it will have a non-zero value, otherwise it will be 0. So you can see here both mz are 0. So in this case delta m is equal to 0. Okay, delta m is not changed, but you should have delta m is equal to plus minus 1 to get a non-zero value. So the answer should be 0. So okay, so for the PhD students it will be very easy, but for IPhD it is not quite knowable. Okay, now this problem is doable for IPhD students. This is a easy problem for IPhD students also. I will zoom a little bit. So here is the configuration. Okay, you can see here is the configuration. You can pause the video and look at the configuration easily. Okay, and the question says that the given figure shows some charges and their coordinates in xy plane. The electric potential, you have to find the electric potential. Okay, so here is the configuration. I will draw it again here. So here is q, it's is 0 d. Here is minus q, it's 0 minus d. Here is a charge 2q and its configuration is d0. D0. Here is a charge minus q into 2d0, minus q 2d0, minus q minus d0, minus q into minus d0. Okay, so what is sum over q? What is sum over q? Q minus q 0, 2q minus q minus q, so it is 0. Okay, so no monopole term exists for sure. Now what is the dipole moment of this configuration? So this is x direction, this is y direction. So let's first write the py. Okay, so p, what is p? P is equal to sum over qi into ri. This is p, definition of dipole moment. Okay, respect to origin. Okay, so now qi ri. So here in this all three charges are in x axis. Okay, so this terms has y is equal to 0, and I mean this charges has the coordinate y is equal to 0. Okay, so py, so here it will be qi yi. Okay, because we are looking at the y component of the dipole moment. So these three charges had no contribution to the y component of the dipole moment. These two charges have some finite y value, y coordinate value. So this charge is q, and its y coordinate is d. Okay, now What about this charge? This charge has a value of minus q and the coordinate is minus d. So minus minus is plus. So it is 2qd. Okay. Now what is px? You can similarly show that these two charges has no contribution towards the px, the x component. Only these three charges as component. Okay. So what is px? Px is equal to sum over qi into xi. Okay. So for this charge, it is minus q and its x component is minus d. Okay. Plus this charge has value 2q and component is d. Plus this charge has value minus q and component is 2d. Okay. So here 2qt, here minus 2qt, these two will cancel, and here minus minus plus, so it is 5qt. Okay. So what is the net dipole moment? Net dipole moment is equal to qd into I hat plus 2j hat. Okay. So what is now the formula for potential? Formula for potential is P dot R by 4 pi epsilon naught R cube. Okay. So QD by 4 pi epsilon naught R cube R dot I hat plus 2 into R dot J hat. So this will be your answer. So it is a doable problem for the IPHD students also. Okay. Okay. Now let's look at the third problem. Third problem is also a easy problem. Okay, so it's a problem from rotational mechanics. The problem is pretty straightforward. That here is a it is a disk. You can pause the video and read the question for a minute. Okay, and give it a try by yourself. So it is a disk, and here is the string, and it is rolling and falling down. Okay, so what is the center of mass velocity at time t? Okay, and it is purely rolling motion, not slipping motion. Okay, so it's a pretty straightforward theory of rotational mechanics, and it is also a doable problem for IPHD. Okay, so here is a tension T, it is a mg downwards. So what is the acceleration of the center of mass acceleration of this disk? Ma is equal to mg minus t. Okay, now for pure rolling, we know that torque should be I alpha. Okay, and A is equal to R alpha. So T, the torque about the center of mass. So this force is acting at the point center of mass. So this force has no contribution toward torque. Only the tension T force, the tension force has contribution towards the torque. So it has some finite value R from the center of mass. So T into R is equal to I into alpha. Alpha is the angular acceleration and I is moment of inertia. Now for pure rolling, alpha is equal to A by R. So T is equal to IA by R square. Now for disk, you know that I is mr square by 2. So it is equal to ma by 2. Now you can easily solve that ma is equal to mg minus ma by 2. So you can solve that a is equal to 2g by 3. And of course it's downwards. Okay, so it is falling down. So the velocity at a time is equal to minus 2gt by 3 pi hat. Okay. So it is simple. It is also simple for IPHD students also. Now let's look at the fourth problem. Fourth problem is it's a not very tough problem, but you should apply a little bit of trick, because otherwise you have to do lot of calculation and you will be lost. Okay. So this is the problem: quantum particle in this kind of potential. You know the wave function for this. Okay, and it is on the ground state. Okay. Now what is the expectation value of this operator? Okay. So now let's first write the operator O. O is equal to xp plus px. Okay. Now write the operator form of p. So ih cross x del del x plus p is del del x into x. So what is O phi? Now at this moment, don't write the form of phi. Okay, first do a simplification with the notation phi, and then you will put the value. So what I am trying to say, that x del phi del x, okay, plus del del x into phi. Okay, Now this thing you know how to. Here are two terms and there is del x, so you can do the partial derivative. So keeping x constant, you will get a del phi del x. So it will add with this term. So it is 2x del phi del x. Okay, plus phi. So this is O phi. Now what is phi O phi? We will simply have integration 0 to L. Now 2x phi del x plus phi square. Okay, dx. Now what is 2x phi del x plus phi square? Phi is root under 2 by L sine pi x by L. So del phi del x is root under 2 by L. Don't forget the pi by L because you are differentiating this term, so coefficient of x will come out. So don't forget this pi by L. It will come out. Okay, so this is del phi del x. So you will get 2x into 2 by L into pi by L into sine pi x by L cos pi x by L plus phi square. Phi square is 2 by L sine square pi x by L. So okay, now let us simplify a little bit. Now 2 sine x cos x is sine 2x. Okay, so let this take this term common, so 2 pi L square x into 2 into sine into cos. Okay, so sine 2 pi x by L plus 1 by L, 2 sine square theta is 1 minus cos 2 theta. Okay, so you have to do integration of dx 0 to L. Okay, so now what will this term give? Okay, so you know that phi squared dx mod phi squared dx 0 to L will simply give you 1. Okay, so this term will simply give you 1. Don't bother about this term, only you have to calculate this term. Okay, so 2 pi by L square x into sine 2 pi x by L dx 0 to L. Now do a by parts integration. X integration of sine is minus cos. Okay, integration of sine is minus cos 2 pi x by L divided by 2 pi L. Don't forget this dividing by 2 pi by L because the coefficient of x. Okay, 0 to L minus this derivative of x, this is 1, and again this integration of minus cos, that is minus sine, that is sine 2 pi x by L by 2 pi by L whole square. It is also 0 to L. Now what is this term? Sine 2 pi minus sine 0. It doesn't contribute. It will 0. What will be this term? When you put the value L, it will take a value L. But when you put 0, then x will be 0. The whole term will be 0. So only the upper term will contribute. Okay. So 2 pi by L square into minus L and cos 2 pi. What is cos 2 pi? Cos 2 pi is 1 divided by 2 pi L is equal to simply minus 1. Okay. Now this term is 1, this term is giving you minus 1. So overall 1 minus 1 is 0. So overall is 0. Okay. So this is 0 and this is a bit of calculation, but always go with this method. Okay. First simplify in this way. Don't put the value of phi, the form of phi instantaneously here. First simplify it in this way and then you put the value of phi. Okay. The form of phi. This is problem 5. Pause the video and read the question first and try it, then look at the solution. Okay, so here is a 2D plane and a random worker. It can go x-axis with probability half and or y-axis with probability half. So the distance from origin after n steps is denoted by Rn. So what is the mean square displacement? Rn square. Okay, so Rn square is xn squared plus yn squared. So average of a plus b is average of a plus average of b. Okay. Now what is xn square? Okay. Now what is some quantity, say a square? It is simply average of a whole square plus delta a whole square, right? So we will use that. That is average of x whole square plus delta x whole square, and simply here is also average of y square plus delta y whole square. Right. So what is average of x? It is n square p square. Okay. And what is delta x whole square? It is n p q. Okay. Now what is average of y square? It is also in p in square p square. I should write it as p1 q1 and p2 q2. P2 square plus n square into p2 q2. Okay. Now p1 p2 q1 q2 all are half. All are half. Okay. So it will simplify to n square plus n into 1 by 4 is equal to n into n plus 1 divided by 2. Okay, so yeah, that's it. This is a good problem from quantum mechanics from IPhD perspective. For IPhD perspective, it is not a doable problem because there might be a bit of confusion because they don't know the concept of adiabatic approximation and certain approximation very well at this point, because this is in the part of time dependent perturbation. So they don't know time dependent perturbation in BSc level. Okay, so this is not for IPhD, I am guaranteed. Okay, so don't worry about that. So let me do the problem, but for PhD perspective, it is very easy. So pause the video and read the question first. So first, it is in this form. The length is L, and you know the what is the energy value, and they said that suddenly, let me point out the word. Yeah, they told that suddenly it will move to 12. Okay, so the what will be the probability that E1 not is equal to EG? EG is the for this configuration and E1 is for the 12 configuration. So to do this problem, let us first find that what is probability of E1 is equal to EG. So if we find the probability of E1 is equal to EG, so finally we can subtract, we can do 1 minus P to find the probability of E1 not is equal to EG. Okay. So we'll first find this. Okay. So what is E1? Is n square pi square h cut square by 2m into 2l square. Okay, so length is 2l now. And what is Eg? Eg is pi square h cut square by 2m l square. So to match this two, n should be is equal to 2. So this states that the in when the length is 2l, the wave function for this 2l, the length 2l dimensional potential well, the length of the potential well is 2l. The wave function should be the second excited state. Okay, I mean the first excited state. That is root under 2 by 2l sine 2 pi x by 2l. Okay, so for n is equal to 2, that is 2 pi x by 2l. So this is the wave function. Now some one of my friends said that the wave function doesn't change for a sudden suddenly when you change suddenly. That is not true, because when you change suddenly, the wave function can go to any wave function, I mean it can go to any higher excited state. Okay, all transitions are possible. If you do it adiabatically very slowly, then ground state will remain into ground state, then the probability will be zero. Okay, but as is mentioned, it is that it is done very suddenly, very quickly, so any wave function is possible, it can go to any transition. Okay, so here 2 3 n value of n 2 3 n any value is possible. Okay, so he did a mistake, because this concept is very I mean not very known to the IPhD student. It is I said that sudden approximation and adiabatic approximation concept. Okay, so now look at the solution. So what is the probability? So a probability amplitude. What is the probability amplitude for E1 is equal to EG? So root under 2 by L into root under 2 by 2L sine pi x by L into Sine 2 pi x by 2l. So this 2 will get cancelled and you will have a sine pi x by l dx 0 to l. So 1 by root under 2 into l into 2 sine square theta 1 minus cos 2 theta. So it will simply give l. So it is 1 by root 2. Okay, so I am not doing this integration. It is easily doable. You can solve it. Okay. So what is the probability that E1 is equal to Eg? Probability of E1 is equal to Eg is 1 by root 2 square is half. So probability of E1 not is equal to Eg is 1 minus half is equal to half. Okay. So yeah. Now 1 minute. Just a minute. Just a minute. This is sixth problem. Okay. This is the seventh problem and it is a good problem. I will say it is doable for IPHD, but it is a standard good problem. This has a missed concept of coefficient of restitution and also elastic collision. Okay, so that these two mixed concept. Okay, so this problem is a good problem. Okay, in this TI for example, other problems are not. I mean, not as standard as TI for level, but this problem is a good problem as a TI for level. So pause the video and read the question first. So I will read some few statements. So here is a ball A dropped on the floor from height h and it bounces up to height h by 4. So it will drop from height h and bounce back to h by 4. So there is definitely some coefficient of restitution. Okay. And then now the identical balls A, B are dropped together from height h. So they are dropped together from height h. And how high does the ball be bounce on the first bounce? So the thing is, when A comes here, A will rebound, A will go in upper direction, but B has this direction V. So it will collide with B, and B will then have some velocity after the collision, and then how high B will go. This is asking. They are asking basically this thing. Okay. So yeah. So first, what is the coefficient of restitution? So see, height h1 is h by 4. I mean the after rebounding it will going to h by 4. Okay. So you know that v square, suppose v1 squared by 2g is equal to v squared by 2g into 4. So okay. So v1 is simply v by 2. So e is half. V is 0.5. So if it is colliding with a velocity v, it will move up with a velocity 0.5 b. Then can it will reach h by 4. Okay. This is the scenario. Now think of this scenario that a will going up with a velocity. Now let us denote v is equal to root under 2gh for simplification. V is equal to root under 2gh. So it will going up with a velocity v by 2. So it is say plus y cap. And at the same moment, v is almost touching it and going in the negative y direction. It is in the negative y direction with a velocity v, that is root under 2gh. Okay. So after collision with A, what will be the velocity of B? This we have to found. Okay. Now, if you know the formula for elastic collision directly, then you can do it very quickly. Actually, I remember that formula. Otherwise, you can also derive it very quickly from momentum conservation and energy conservation. So, after collision, suppose the velocity of ball B is B. Velocity of ball B is UB. So, UB is MB minus MA divided by MB plus MA into Vb, that is initial velocity of B, plus 2ma divided by ma plus mb into Va. Va is the initial velocity of ball A. This is the initial velocity of ball B. Now ma and mb are similar. The first term is 0. 2m divided by m plus m, that is 2m by m, 2m by 2m into Va. Va is v, so it is v. It is so after collision, ub, the velocity of ball b will be v. And what is its direction? Its direction is the y hat direction. Okay, so it will. So if you know the for theorem also, so when two masses with some velocity v1 and v2 moving eachward and go through an elastic collision, their velocity will be exchanged. You learned in from class 11, okay? So B will moving up with a velocity v by 2, right? Yeah, v by 2. V by 2. Sorry, it is moving up with a velocity v by 2. Okay. So what is height of B? That is v squared by 4 into 2g. That is h by 4. Okay. So this is a good problem. I mean, good problem in mixed concept. Okay. So this will be the right answer. Okay. So these are the first seven problems, and in the next part, I will discuss the another seven problems. Okay. Thank you.